Today we are going to solve a question, and the question is this: we have to find the sum of the roots of the following equation. So we have this equation: x over x minus 3 plus 4 over x minus 2 equal to minus 4 over x minus 2 times x minus 3, and we want to find the sum of its roots. So we'll try finding the roots first, and let's see what are its roots. And so on the left hand side we have two fractions, so we can take the LCM, and when we take the LCM we get x minus 3 times x minus 2 as LCM, and in the numerator we have x times x minus 2 plus 4 times x minus 3 equal to minus 4 over x minus 2 times x minus 3. When we multiply this x with x minus 2 we get x square minus 2x, and when we multiply 4 with x minus 3 we get 4x minus 12 over x minus 3 times x minus 2 equal to minus 4 over x minus 2 times x minus 3. So we are interested in finding the values of x because we want to find the roots so that we can find their sum. So to find the values of x, we can get rid of these denominators by multiplying both sides by x minus 3 times x minus 2, and when we do that, on the left hand side and on the right hand side the denominators get cancelled. So we are left with x square minus 2x plus 4x minus 12 equal to minus 4, and this minus 4 can be shifted to the left side, and we get x square plus 2x minus 12 plus 4 equal to 0. So if we solve these two terms we get x square plus 2x minus 8 equal to 0. So we get a quadratic equation, and we are interested in the values of x, which are the roots. So but we can find the sum of the roots of this equation without finding those roots, because we have a formula for that, and the formula for the sum of the roots of a quadratic equation is simply minus b over a. So minus b over a in this case is minus 2 over 1, because b is 2 and a is 1, so we get minus 2 over 1, which is minus 2. But it turns out that minus 2 is not our required sum. It is wrong, and the question is, why is this not the sum or which we require? So we can try finding the roots of this quadratic equation to check that how is this minus 2 not our solution. So let's find out the roots for this quadratic equation. So we can solve this quadratic equation by middle term breaking, and we need to find those two terms which when solved give us plus 2x, and when multiply give us minus 8x square. So those terms are 4x and minus 2x. They solve to give us plus 2x, and when they are multiplied they give us minus 8x square. So from first two terms we can take x common, and we are left with x plus 4, and from next two terms we can take minus 2 common, and the same x plus 4 is remains. So now we can take x plus 4 common from both the terms, and we are left with x minus 2. So these two are factors and they are equal to 0. Their product is equal to 0. So whenever this is the case in mathematics, that the product of two things is equal to 0, it means that at least one of them is 0, and this or basically indicates that this is not the or which is used in English, that either this is 0 or this is 0. Both of them can be 0. It means that at least one of them is 0. So x is equal to minus 4 uh, from this equation, and x is equal to 2 from this equation. So we have the values for x, which are minus 4 and 2. And when now we have the roots, so we can actually calculate the sum. So when we calculate the sum of these two, we get 2 minus 4, which is minus 2, which is exactly what we got when we used the formula for sum of the roots of a quadratic equation. So and I told you that is not the answer. Our whole we want to know why is that not our required sum. So let's check these roots by putting them in our given equation, minus 4 and 2. So when we put minus 4 in our given equation, we get minus 4 over minus 4 minus 3 plus 4 over minus 4 minus 2 equal to minus 4 over minus 4 minus 2 minus 4 minus 3. So we get minus 4 over minus 1 plus 4 over minus 6 is equal to minus 4 over minus 6 times minus 7, and this negative shifts in the numerator, and we are 4 over 7, we get 1 of 4 over 7 plus times minus 4 over 6 is equal to minus 4 over minus 6 minus 7. So actually I shouldn't have put this equal sign between these two, because we want to check whether they are equal or not. So I should have found the left hand side separately and the right hand side separately, so my bad. So 7 and 6, when we take the LCM of this, we get 42, and when we solve, we get 24 minus 28. And on the right hand side, this negative 6 and negative 7 is when multiplied, they give us 42, and we get the answer minus 4 over 42 on the right hand side. On the left hand side also we get minus 4 over 42. So in this step, we can say that these two are equal, and we can put an equal to sign between them. So minus 4 does satisfy our given equation. Now we'll be checking 2, and when we put 2 in our given equation, on the left hand side we get 2 over 2 minus 3 plus 4 over 2 minus 2, and when we solve it, we get 2 over 2 minus 3, which is minus 1, plus 2 minus 2 is 0, so plus 4 over 0. And on the right hand side we get minus 4 over 0 times minus 1. So on the left hand side we are getting 2 over minus 1 plus 4 over 0, and on the right hand side we are getting minus 4 over 0. So this is the problem basically, that when we put 2 in our given equation, which was the value of x which we got from that quadratic equation, the equation in our question, it becomes undefined, because we get 0 in the denominator. On the left hand side we get the denominator equal to 0, and on the right hand side we also get the denominator equal to 0, and this is the problem. Again, this equal to sign shouldn't have been put by me in here when we are checking, because this is not equal, and so I shouldn't have done this. So it basically it is just telling us that the question becomes undefined. So this 2 is not the root of our given equation. So if this is not our root, that means that this can't be counted in the sum, and so we have only one root which satisfies our given equation, and that is minus 4. So the required sum is minus 4. So what does this tell us? This tells us that whenever we have an equation which is reducible to quadratic equation, it is not necessary that the quadratic equation which we got from our original equation, that the roots of those quadratic equation must satisfy our original equation. Here, our original equation was an equation which involved fractions, and it involved variables in the denominator. And whenever that is the case, it is possible that the roots of that quadratic equation do not satisfy our original equation. And we are interested in finding the sum of roots of our original equation, not the roots of that quadratic equation. So, uh, we must keep this in mind, and our sum is -4.